What's going on, boys? Welcome back to another day. Oh my god. Well, I've got a little bit of an idea, alright? And it's called not live streaming. That's right, I'm not live right now. I'm literally just hitting the record button, and I'm going to record my entire day and then just upload that as a VOD. It's going to be like a live stream, but I'm actually going to be able to take breaks and like walk away from the keyboard. For example, I can just do this and just pause the video on the fly like that. How fucking sick is that? Anyway, let's get just fucking jump straight into today's work, shall we, mate? Actually, before we do that, as a substitute for like the live kind of chat interaction, that's obviously going to be a no-go. But just leave your comments down in the description. I'll try my best to like answer questions and stuff like that down there. So we'll just substitute that for chat, and yeah, I feel like that's all I gotta say for this little intro thing. Let's just hop to it. First things first, we of course have got to get Brain FM pumping because, you know, what would a work session be without some subtle tunes going on in the background that you don't have to worry about? Me likey. Alright, let's get cracking. Now, since the last video, which I believe was just me fucking around with LUTs, I've figured out how LUTs work. I will demonstrate that real quick. Where are you? Mr. Config file. And I've implemented a day-night cycle with it. So, you can see the little sun, hello, moving around the background there. And then we got the moon right there. It's a bit scuffed, but it gets the job done. You know, basic, but it works. So that's LUTs working. That's literally all I wanted LUTs for. If we look in, the LUTs folder, it's just interpolating between these like different phases of how the color should look, right? That's pretty cool. But I'm disabling that for now because it's it needs some fine tuning, and I just want to focus on other things. I've also gone and implemented, kind of. Wasn't that much of an implementation. It's literally just, fucking, where is it? I've just completely boofed my repository into a new repository, and that's messed up all of my cached files. So I've got to figure out where I was. Something world net. There we go. So I did a bit of world generation. We're generating the trees and some roots beside the trees. Also have a chance of spawning in. Ideally, these, when you you know, first spawn in, you come over them. I can destroy them, and they will basically just drop like the small little things of wood. So you can't chop a tree down straight away, but you can get that, and then also some flint, which I'm looking to spawn in right now. And then, you know, just craft the flint axe, and then go chop down the tree. Cool, glad we're getting a crash there. Sweet, let's ignore that. Yeah, so what I want to do is, I want to do some purling noise for these flint clusters because it feels a bit icky. Just like that. I don't know. It's possible, but I feel like putting some some old mate pearl in for it would be a good idea. Now why the fuck is that crashing? It's trying to do trying to load in a sound file, but it's not there. So I did a big rework of the sound system, so it's gonna not the sound system, the resources. So all the everything's fucked right now. Oh, the reason this is fucked is because I don't actually have this plugged into the resource system yet. Let's just make sure we're on the right scene. Okay, cool. How's the volume as well? Ba 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 ba. Probably turn it down a bit, eh? Turn this guy down a little bit. Ba 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 ba. Yeah, should be good, mate. Should be good. Alright. Yeah, so I need to pipe this into the resources, which I'm not currently doing. Let's just do that real quick. Why not? While we're here, you know? While we're here, let's just go ahead and do it. Now, ideally, I loop over all the files in here, and then we'll just do like a switch on the extension. So go case, PNG, case, WAV. That PNG is going to be all up in there. Cool. And then we've got to do the WAVs. All right. What I'm doing here at the moment for the playing sound is, if we go to a play sound, like here for example, the page flip. We just say, hey, play the page flip, and then what it does is it basically tries and like loads it in right there and then, so it's pretty immediate, which is kind of cringe because you could imagine it like suddenly playing a music file and loading in the music file and then it just stuttering a frame because it has loaded in. You could put it out onto another frame, but still, like, you have to wait for it to play. So I'm gonna move this into the resources, which just get initialized right off the bat, but still have the nice sleek UI, API, like that. So let's get cracking on that. After I sip my hot Milo and coffee. It's pretty good. It's pretty good. I'm gonna sit down as well. Give me a sec. Let me do a desk lowering. Desk lowering, hand crank. Let's go. Yeah, so what I want to do today is I really want to get monster spawning in now that we've got the nighttime. Right after I just do a bit of refactoring with this, plug in the resources, make it good, and then I kind of want to do, yeah, probably the Flint stuff where we do the Perlin noise. I don't know. We'll figure it out as we go. I don't really know what the fuck I'm doing. I'm just kind of winging it, one step at a time, you know, day by day, putting in a little bit of effort here, a little bit of effort there, just slowly but surely getting stuff done. That's all you can really do, you know. Like I've never fucking done this before. I've never actually shipped a game. I've always just been on the hunt for figuring out how to program better and better. And while that will always be like a lifelong thing, I feel like I've kind of reached a point now where it's like, alright, well, we can actually just go ship a game with what I've got right now. And that in itself is an entirely different skill. Alright, we're level. Like, the amount of time so far that I've pulled up to work. Oh, what the fuck did I just do? Sweet. Yeah, where I've pulled up, I've been like, huh, maybe we ditch this and go work on a 3D game. Let's just start up a new project. And well, I'd love to do that. Gotta ship this bad boy. Gotta finish what I started 7 years ago, you know? It's gotta be done. Alright. Sound. Let's hop to it. And the answer to actually shipping something, or just making a game in general, really isn't sexy. It's this. Sitting down at my desk and just working. Day in, day out. There's no real shortcut. No real shortcut. As much as I'd like there to be. Alright, what are we doing here? So the sound's actually being played on another thread. So I had to learn a bit of multi-threading for this, which is actually a lot of fun. Now that I kind of have a little bit of grasp on it. A little bit more of a grasp on it. What are we doing here? So play sound, find table, yeah, we're storing it all in the fucking, god, disgusting. Storing it in a hash table, which is a little bit silly. Oh, they're right here, cool. Sound wave table. So we can just go ahead and delete that. Keep the sound instant stuff here. I'm just sound instance we can kind of keep in its own sound state thing, but for the actual like the underlying WAV file, all the data, that's going to go in the resources now. So let's do that. Okay, so right here, what I want to do is basically wave get WAV. Something like that, right? Get WAV key. And we're just going to assume that we've got the WAV now. The wave. Instead of the key, it's probably going to be like the ID, I'd say. Store that. I also eventually want to do something where I was looking into the perfect hash function the other day. It's basically you take a set of all the known things that you need to hash and generate like a hash function based off of that. So there's like no collisions or anything, it'll just map perfectly into whatever slot you want it. Which I think could be a good candidate for the resources because we do know all of them ahead of time, right? They're all just here. You're not creating resources at runtime, really. Like dynamically, I should say. But yeah, anyway, I digress. Another thing for another day. Wave. So we're in the WAV. Let's go over to the resources and say get WAV. And they're all the resources now are all just in a megastruct. The resources. Like I didn't really bother splitting them up into like things. Different. I could have done like an enum, not enum, what's it called, union, but I guess it's kind of just easier this way. So let's make a new thing for the WAV, and then we're gonna take all of the sound wave stuff and chuck it in here. Sweet. Key. probably do want to hold on to the path, right? Put that in for later. Sample buffer, and then the channels. So that's all we really need for the WAV. Wave key. Now, do we want to store the key or the ID? Potato, potato, they're kind of the same thing. It's more of like, you store the key if you want to like, you use the key in APIs because you just want to type out the resource instead of like it's a human readable version of the ID, I guess. Kind of like an enum. So we'll just change this to ID. Resource ID, wave ID. Spell resource correctly would help quite a bit. How are we doing? On the right seat and everything. That's cool. I'm very paranoid about leaving it on the wrong seat. Just going like an hour with me just like this. Okay, sweet. So we got that sound instance. WAV. I just need to initialize it. Sweet. Get WAV. Oh, I still need to do the whole get WAV thing, don't we? Yeah, alright, res. So the good thing about this resource system is it's very like I don't have to keep writing these things over and over again for each and every type of resource. It's just this one kind of like base find resource, and we pass in the name. Every single name of every single resource is unique. So it just works. So then we're gonna assert. I feel like for these, like the find resource, this could fail, right? This is fine to fail. But if we're saying like get WAV or get sprite or get texture, we're assuming that, hey, this is actually a thing that we want. So that's why I'm kind of doing an assert here and being like, yo, gotta make sure this is valid, homeboy. Is valid and res.flags. So it's gotta be a WAV, right? Sweet. Sweet. That should be good. Just gotta actually make them now. What do we got? We got flags. Yep, we got the WAV up here. Should be good. Sweet. Now, how are these bad boys getting initialized? Right here, sound instance create. Nope, that's not what I want. Sound wave create. This is what I want. Sound wave from key. Delete that. Fuck you. Alright, sweet. File path, file data. I am the dictator. Yeah, so everything in the WAV, I'm just assuming it's going to be 16 bits per sample with 2 channels. And it's got a fixed sample rate. So I'm an evil dictator. That's kind of the good thing about doing everything this way, is that you can kind of just assume that it's always going to be like this, and then just go. And if you do need something else, you just add support for something else. Like right now, I don't have to sit here and go like, oh, but if it's 24-bit, we gotta like, you know, convert it. Or if it's like a fucking like MP3, we gotta change it. Or if it's like an ORG, we gotta change it. OGG. It's just like, let's just use WAV. Let's just use 16-bit WAV and let's just fucking load them into RAM every single time, mate. Call it a day. No streaming, no nothing. We'll see if that works, you know. We'll see if that works. Anyway, what are we doing here? So, reading the entire file. We're getting the WAV header. Sweet. So, this is everything that I want here. Push allocator, permanent allocator. Yeah, so we want these S prints and shit to be permanent. Retype file, yep. Yep. Yeah, WAV header, yep. Cool. Wave. Alright, so this is what we're going to change. Basically, what's going to happen here is we're going to create a resource. Create resource with the name of what exactly? We're gonna have to strip the file name. Alright, we're also gonna have to the file path we've already got, right? We've got it right here. So we go read entire file. Cool. Strip name, yeah, like that, and then we create a resource. Sweet. I'm not sure if we even need to push this allocator. What we got here? Probably in the read entire file. Like, I don't exactly know how this is. It's one thing about Joe, I'm really not the biggest fan of this whole, like, push allocator thing. I know it's kind of necessary if you're calling out to another API and it, like, doesn't have memory arenas. So, i.e. everything outside of what I'm currently doing. Because that way you can, like, override the allocator. But, like, I think the best solution here is just to use memory readers. But it's not a perfect world. So, gotta roll with it. What am I doing? Just fucking blanking out here. Path strip extension. Cool. Create resource. Cool. Read entire file. Yeah. I'm wondering how this is getting its allocator. Like, at what point do we get an allocator? File open. What do we got? Like, I wonder what's actually happening here. I haven't really looked into this too much. I have no idea what the fuck is going on. It's calling create file W, which is just Windows. And it just does its Windows thing, I guess. Alright, that's just a file open. It gives us a handle to the file. And then read entire file. There we go. There it is. Alloc. Yeah, so that's why we're pushing the permanent. Because we really just want it to be permanent. Which makes sense. Like, that's the one thing that I don't really like about it, is because it's hard to tell, like, what's declaring memory, what's allocating memory, and what isn't. Kinda sus. Alright, good. What the fuck was I doing? I was doing something. Jesus. Alright, so create the resource. Pushing the allocator, the read entire file. Right, yeah, I was going on a little rant about how I don't like this. Like, the typical approach I would do is, like, if I was in control of this API, I would just say everything that allocates memory, you just have to pass in an arena. So you know exactly if it's allocating memory or not, just by whether or not you have to give it an arena. I really don't like this whole fucking push pop thing, but who cares? Who cares? Minor issue. Entire file data. Like, that whole allocator thing is really only possible if I wasn't lazy and wrote this myself. So there's no excuses there, really. Header. This isn't doing anything, this is just referencing existing stuff, right? I don't think there's any allocation going on. I guess we'll assume. It's not like it matters, we push the allocator anyway. Alright. So. Got the strip file name. Inserting all the stuff. Now we are fill in resource. Cool. So res dot, what do we got? Sample buffer is equal to samples. Res dot channels equal to format dot init channels. And that's really all we're doing. Because the create resource is like doing all the other stuff, like grabbing the ID, the name, all that kind of shit. So we don't have to worry about that. I feel like that should just work. Should just work, mate. Alright, next up. Damage control. Let's fix stuff. We don't need the table anymore. Sound wave from key, hey? It'll just be get wav. Sound wave dot wave ID now. Should I just get wav or get wave? Keep it a wav. Sound wave ID. Right, so we're gonna have to also do this. There's probably a better way of doing this. Also make sure I use resource ID just in case I change that. In fact, it's a U16 anyway, what the fuck, dude? I've actually just been, like, this is supposed to be a U16. Alright, go off, I guess. Just been casting it down. Get wav, and then it's just gonna return right into the fucking table, mate. Clean. Which is good. So, the get wav here, this is actually going to find the resource, so it's a bit inefficient at the moment until I get the perfect hash function in, because it's actually looping through all the resources and like matching the name. Ideally the perfect hash would just hash the name and then you get the index straight away out of that. But future problems. What do we got? Okay, of course, have got to return. Also, I probably want to do some checking on this. Like, make sure it exists and everything. I mean, if we've got the ID, then... who cares? Future Randy problem. Sample rate is undeclared. Cool story, bro. We're gonna put you out here. Sweet. Soundwave's no longer a thing. Suck my balls. And we are compiling. The next question is, are we legitness? Nope. What do we got? Resource wood already exists. Ah, okay. So, we've run into an issue. I knew this was going to happen sooner or later. So, what's going on right now? Let's go on the sound effects. Look at this. Wood.wav. Yet, we've also got a texture called wood in here somewhere. So it's clashing. I'm thinking It's tricky because of the API, we kind of just want to go like, we still just want to go page flip and it assume that it's a sound. Ooh, so in the API we could go like, hey, get WAV. Oh, actually, I don't know. Yeah. Like we could assume, because we're calling through here, we're going, yo, and we'll just tack on the .wav at the end in here. That could be cool. In other words, we hash the entire sound.wav, or the wood.wav, and the wood.png. That way we get distinctions. That'll work. At least I hope so. Let's find out. So instead of stripping the entire file name, what we want to do is path strip extension path. Yeah, so we just won't strip the extension. Path file name. It's a slice of the input string. Path file name. Yep, that's what we want. Sweet. So the strip name is just going to be the file name now. Right? And now that's going to crash because we're going, hey, char idle not found. Because now it's supposed to be char idle.png. And the way we tack that on the end is with the get texture. Spoot. Get texture, find resource. We can do a tprint here of .png. Something like that would be legit. Same with the sprites. These are just going to be PNG as well. Yeah, right. The good thing about the model that I just did is textures and sprites, they don't actually have two separate resources, they're the same. Like, they've just got both of these filled out. That's why I didn't really want to do a union. Because there is, like, some things that just apply to everything. Like, it's more complicated than it just being, this is just a texture, this is just a sprite, this is just a WAV. For example, we want things to be hot reloadable, and we want that to apply to all of them, so it's like, I don't know. I guess you could still achieve that with a union. You just pick where you put it. Oh well, who cares? Who cares? I'm rambling. Get sprite. Cool. And now this. Down here, change to a .wav. And then, bada bing, bada boom. What do we got now? Texture white text not found. Right. that's an issue. Because now it's trying to tack on the PNG to that, but it's not actually PNG. So instead of get texture, I'd say alright, yeah, there's one of two things we can do. One of two things we can do. What are we at? 384. We could change this to .png. Or we change this to get resource, but it's a texture, so we kind of want the texture. It's a whole thing, bro. That'll just work, I think. What do we got now? Okay, now it's saying white text.png not found. Great. Texture. Why is that not working now? Oh, yeah, because now it's trying to do like .png. Okay, so we can't do that. Instead, when we create the texture, that's what we want to do. So we gotta go render. Right here. Right, so I want to create the resource. Put a PNG on the end, just for safe measure. Cool. Now we got a different problem. Flint.png not found. Okay, so we got Flint.png. That's weird. Get texture. Why is that already? So that's storing the texture key. God, this is a fucking nightmare. So that's trying to get the texture key. We don't want that happening. 725. Also, to make things more clear, real quick, let's make this be like, hey, res name, tprint, we'll put that into there, and then we'll do that. Now, there is a Vim shortcut for doing this. What do? C, this, B. Yeah. We Vimmin', boys, we Vimmin'. Alright, so that should give us a more clear error message. So what it's trying to do is it's trying to do Flint PNG, which of course ain't very cash money. Where was this? It was in main. It was, I think, render somewhere. Get texture. Yep, so it's trying to get it from the texture key, which isn't what we want. Don't want it to be the texture key. texture from sprite. Cool. Just say text, get rid of the name. And then fix the errors, get texture, it's already there. Texture. Cool. I need to overhaul this is a mess. If texture dot name is equal to 0, then yep. Okay, and then we just pass in the texture there. Hopefully that is good. Interesting. Now the metadata isn't being matched correctly, I don't think. I think that's what's happening here. So, we will make it match. Oh, okay, so now that's tricky because in the resource res.mdes, in here, or actually no, because we're defining this to be all textures. Okay, we can assume that that's a PNG then. Cool. I was thinking that was going to be a clash, but nope. Nope. Find a resource name. Okay, so name to do this. Tprint. Same deal, just add a PNG on the end. And that should fix things. Yeah, there we go, baby. And now when we pick this up, it's still gonna crash. Wav airswing.wave.no. Airswing.wav not found. Now, are we playing nice with these guys? What's happening here, mate? Find a resource. Play sound, airswing. I'm thinking that maybe it's not even being initialized. I don't know. We'll see, mate. We'll see. What I'm gonna do is I'm going to log all of these guys. Res.name. Yeah. Loading them. Airswing.wav, yeah. It's there. Why isn't it being picked up then? Oh, I know what's happening. I know what's happening. Maybe. Why is that assert hitting? Ah. This assert is hitting. The thing is, I've got this assert being multiple things. This is the part that's fucking up. So I need to be careful about that in future. That was a bit silly of me. Find resource, get... Yeah, so this needs to be split into 2 asserts, or 2 error messages. And then this one is basically saying it doesn't have the WAV flag. Tprint doesn't. Resource doesn't have WAV flag. So that's the one that's actually being hit. There we go. Doesn't have WAV flag, which we forgot to add. And by we, I mean me. This is all on me. Yeah. So we go res.flags. Add in the cheeky.wav. Now, there we go. You can play in the sound. Ooh, okay, so the metadata for the pivot point of my hand is fucked up. Which makes sense. Because I'm not actually, I don't have the hand metadata yet. We'll solve that later. We will solve that later. Alright, now that that's working. It simplifies things a lot. Let's just commit that. Moved sound, we'll say move.wav to resources. Now the good thing about all this, moving everything to the resources, I also want to do, I also want to move the shaders to the resources, because then I basically implement hot reloading, and I can get hot reloading for every single one of these, which would be fucking sick, especially hot reloading with shaders. I wonder what that's even gonna look like. I'm excited. Another day though. Another day. Next time I need hot reloading on the shaders, I'll implement it. Alright, so we've got sound back in. Right, bug fixed. What was I doing before I found that? I don't even know, dude. I don't even know. Probably talking about what I was gonna do today. What are we doing? What are we doing? What do I want to do? Monster spawning, resource generation. Alright, two things. I'm gonna do Pearl and Noise with the flint. Monster spawning. I want to do Pearl and Noise. Let's do that. Now, I have made a friend yesterday, and his name is ChatGPT. I've been putting off like trying this out for a long time, especially in like the context of coding. So I don't know. I just didn't really think that it would be helpful, but it's very helpful. When I was working on Lots the other day, I was stuck on this like one issue. I just couldn't get the sampling to be right. And I was like, yo, ChatGPT, my homie, what to do? And he spat out some facts. And it's not like right code, but it gave me like an idea for what to do, or like what I was doing wrong, which is like this right here. It was like, he was times it by 15. I say he, it's more of like an it, right? I'm gonna call him, you know, homeboy ChatGPT. Yeah, and he was times it by 15, and I was doing 16. And I was like, oh, that's my problem. Silly fucking goose, of course that's the problem. And since then, I've just been going fucking ham, just asking him all sorts of shit. Like I was writing a what was I doing? I was doing like keyframe interpolations for right at the end. Thanks for your help. You're welcome. I'm glad I could help. If you have any more questions, feel free to ask. Happy coding. How fucking cool is that, dude? So cool. Again, spat out kind of gobbledygook shit, but gave me ideas as to how to do things, which I think is kind of the key here. It's very thorough with like me being like, yo, test this out. Yeah, I don't know, man. It's pretty cool. And right here, just giving me a Perlin noise algorithm for sampling in one dimension. So I'm literally just gonna take this, slap it in, and we'll see how we go. I've done Perlin noise before, so I know what's going on here. It's just the effort it would take me to go back into my old code, figure out what I did, or just like rewrite a new one from scratch, like from memory. Like I can just reference this, and maybe not all of it's right, but it's giving me like the general vibe of what to do. So it's kind of just really OP. So let's get to it. Let's get to it. What do I want to do? Alright, let's go to the world init. Place down a nice little bookmark there. And let's do some Perlin noise for Flint clusters. Let's do it, mate. Let's fucking do it. Alright. Well, first thing I want to do is like Perlin noise. Basically going to create a buffer of Perlin stuff to sample from. Like this is obviously a very silly function right here because it's generating a new array and like creating new data every single time when you call this function. And you're just trying to sample one thing. Oh, actually, no, it gives you. Yeah, it's a little silly, but this right here, gold, mate, gold. So from memory, from looking at this, how Perlin noise works is we have an array, especially in 1D. It's kind of simple. It's kind of simple to just put everything in one dimension. We've got gradients, and we're looping over the entire length of the buffer that we want, right? And we put just random things in there, ranging from -1 to 1. And then, which kind of gives like a, is it -1 to 1? Yeah, it kind of gives like a, I don't know. Figure that out later. And then you just go in octaves. So you have like one big octave, you got the octave count, you just go bang, and we loop over the thing, and we just like sample, like take the sampling point, and then we find to the left and right of it, and basically do a linear interpolation of it, which will give us one octave of the Perlin noise. But then the key here is to do the next octave at like a different frequency. Sampling at a different frequency. And the end result gives something like this, where it looks nice and kind of natural, instead of this. Like this is kind of like what you would get if you only did one octave, I believe. Then this is layered octaves. So, let's hop to it. Oh no, I exited out of my brain FM. No. Delicious water. Cool. So the first thing I want to do is basically create a buffer to sample into. So I'd say something like float. Don't even need to do that. We say, I don't know, 128 to begin with of floats. Float. And then we fill in the buffer. We do it is equal to, or the value in it is equal to random get within range -1 to 1. We can just get rid of the zeros on there. Actually, it's probably a good habit to keep the zeros in. Especially if I go over into the shaders. That's fucked me more than once. Like, if we put the zeros in here, then the compiler doesn't have to do any work to actually cast it to the float. Like, this just gets cast to the float because it looks at, like, hey, the value we're taking is a float, and we can cast this into a float, so may as well just... Anyway, let's just fucking do that. So, we're filling the buffer with that. And now, what we want to do is basically do the sampling of the gradients. That's a pretty good name for it, gradients. I like it. Okay. Amplitude, total amplitude, frequency. There's a constant. Sample index. Generate noise. Wait, so this just generates noise. Ah, so we have another buffer, which is noise. Right, and then we sample into the noise. Ah, so this function is actually pretty solid. I take it back, ChatGPT. I never doubted you to begin with. So this just actually creates a buffer of permanent noise, which is pretty cool. So we could do something similar, but... I wonder, should it be a function? Who knows? Let's just do a function. Oh, I can reuse it. Okay, let's go into resource. Nope. Recycle. Reduce, reuse, recycle. And let's just do this. Bonk. Noise shit. Generate Perlin noise buffer. So we're basically going to have a length and then I'd say we pass in things like the frequency and the amplitude and stuff like that, and the octave count. What's persistence? That's what I'd like to know. Banger incoming. We got a beat, boys. Ramping up. I need to do better audio. Ah well. Should be right, mate. Should be right. Persistence. I wonder what that does. Oh. Of course, he explains it. Length parameter represents length number of points in a resulting array. Persistence controls a amplitude decrease between octaves, and octave count determines the number of octaves to generate. Amplitude decrease between octaves. Right. So you're choosing like, yeah, that makes sense. It's probably kind of dangerous reading this. What if it's just fucking wrong? I guess we just want to be able to fuck around with the values anyway, so... the frequency starts off as 1. And then it gets doubled. And then the total amplitude adds the amplitude. And then the amplitude gets gated by the persistence. Which feels strange to me. Erlin noise function. Khan Academy, goddamn. Blah 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 blah. Blah blah blah. Blah 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 blah. Interesting. Yeah, let's just fucking run it. Let's just run it, mate. So what we're going to do is we're going to return, well, this is going to be constant. So we're basically going to return a length float. This is one of the really nice quality of life things about Jai. It makes like pulling out functions like this a whole lot easier. Like with the auto bakes, the polymorphism and shit. Length, what else do we need in here? Persistence, yeah, so this is happening on the octave layer. Update frequency and amplitude for the next octave. Frequency, total amplitude gets added in, and then the amplitude gets increased by whatever the persistence is. Frequency just gets doubled. I'll buy it. For lack of a better term. Octave count will also be, these will all be constants actually. Cool. Ideally you'd want to control the frequency as well. I don't know. I don't know, man. Actually, not really, because it just gets doubled. Amplitude. Total amp. Cool. So we got the random gradients. Now it's time for the noise. So we're going to loop over the octaves. 0 to octave count. Minus 1, and we'll just call this octave. And then also, in this, I'm going to loop over like the entire buffer. 0 to the length of the buffer, -1. call this it. It'll be fine. Alright, time for the meat. The meat and potatoes. Just gonna copy this. Write it out. Fuck it, I guess. Bang. Alright, sample index is equal to I times the frequency. Interesting. I have what? This? It times the frequency, I'd say. Yep. Left. So we're just gonna follow the sample index. Sample index. This we're gonna make sure is a float. Right. Seal. I'm guessing. Well, now we just go left index plus 1. That also makes sense. These also want to be ints. Then the fractional component is going to be just frac of sample index, I'd say. Sample index, take away the left index, that also works. Same result. Same shit, different smell, you know. Sample index. So, sample index, take away the left. Let's just call this frac. Cool. And then we interpolate between the grains. Oh, I keep forgetting the code's down here for me to reference. Oh god. Left grad. Just not do that. Interpolated. Sure. What we got? 1 minus the fractional component to inverse it, times it by left gradient, plus it by frac times right, which is just a lerp. So then in the noise buffer, at it plus equals calculated times amplitude. Look at that, straight up copying ChatGPT's homework. Love it. Makes life easier for me. Alright, then we'll get a noise buffer, which will just be the length float. Cool. Make sure we put length in here. Alright, so that should be good. And then right at the end we just return the noise buffer. I would like to debug it somehow. How am I going to do that? I guess I can just print the whole thing out. That'll work. I like to visualize it though. I guess I can by like using it as a hide map or something. Alright, let's see if this works. And we have everything in place. Okay, that's it's not compiling because I'm not calling it anywhere, so that's going to give us an error. Perlin. My old mate Perlin. So we got 128. What are the other parameters? Persistence and octave count. What would be a valid value for persistence on the call side? Between the octaves, impelling noise generation typically lies between 0 and 1. A persistence value point is commonly used by default to provide a balanced result. Higher persistence value result in stronger, more pronounced features, or lower to smoother, more subtle noise. Persistence depends on the desired characteristics. Sweet. How fucking helpful is that, How helpful is that? 0.5 is a good default. And then octave count, let's put it to like 4 or something. Sweet. Alright, how am I gonna debug this? I guess first I'm just gonna step into it and see how it goes. Type wanted int. Type given float. Why the fuck would we? Oh, right. Amplitude is not valid. It's called amp. I'm on my way. I forgot one crucial part of the puzzle. Thought something was off. Of course. Frequency times equal to total amp plus equals the amp. And then the amplitude, we are modifying that by the persistence. Sweet. Now we should be good. No idea how much, like, time that has just saved me. Assuming it doesn't introduce a bug that will have me hunting it for an equal amount of time, which I can get just by testing it, you know. Yeah, that's nuts. God, that is OP as fuck. Yeah, let's test this. So we're in just end this shit. What are we at? 915, 951. Did I compile? Probably. Make sure. Alright, let's do it. Show me what you got. Alright, so the gradients are valid. Yep. Sample index 0 octave, so the left is 0, the right is 1, cool. So the frequency is just 1 at this point, so it's just going to be pretty left, right, 2, 3. Sample index to, yeah, so once we get up into the next octave though, frequency is getting doubled. It shouldn't actually even change anything. Yeah. It's not doing any interpolation at all. Like, 'cause it's just, the frequency is getting times by 2. So why would it ever do interpolation? That's what I'm wondering. Maybe I fucked that up. So it also just go out of bounds eventually. Like you'd want to percent it. Yeah, this is all kinds of fucked up. Like if we run that, that's surely just gonna go out of bounds. No? Okay, I'm dumb apparently. What does that give us? What do we got? What does Ultimate Perlin give us? 0, 4, 8, 12, 16. Interesting. Yeah, fucking garbage, mate. Messed up. Kinda messed up, bro. Come on, bro. Why you gotta do me like that, bro? We also got to do something at the end to normalize it, which I forgot to do. I don't know about this, bro. Uh-oh. Okay. It is equal to divided by equal to total amplitude. What are you going to give us now, Mr. Perlin? Curious indeed. Alright, let's steer away from ChatGPT for now. Right, this is fractal noise, not Perlin noise. So doing the what's my jiggies? What's my jiggies, mate? Interesting. Some pseudo random stuff. Interesting. I can't even remember where I first learned how to do Perlin. Minecraft. Whoa. Whoa. Handwritten lines, eh? I really just don't want to use my brain, so I'm having others do it for me. There we go. So the total plus equals to the sampling and the frequency. Sampling it, x times frequency. It's also timesing by the amplitude at the end. Yeah, which makes sense. So we're getting the interpolated value and timesing by the amplitude, and that's going to give us a thing, right? And then next up, adding that max value to the total amplitude. And then the amplitude is being increased by the persistence, and the frequency is just being doubled, which makes sense. Don't really understand why. Someone's like warping between the corners, which, you know, we're kind of just doing here in a simplified manner. It's just not like. There's no real interpolation going on because it's just falling on the fucking the frequency boundary. Like the frequency is just going up by even numbers. So why would we even need it to interpolate? Alright, I guess like adjust the frequency and then find out. Why interpolate when the frequency is increasing, is just being doubled, thus falling on a integer sample index each time. Fractional integer sampling is allows for more flexibility in generalization. The algorithm indicates where you want to sample noise at non-integer positions to simulate animation, fine grain detail, interpolation necessary. Noise for integer sampling, blah blah blah. mean, it makes sense, like... Could the frequency be changed as an input then? Yeah. That's what I was thinking. Yeah, like you just change this to like fucking 0.5, whatever. Something just doesn't feel right still. Like, this ain't... I don't know, man. I don't know, man. .7. Like, if you changed it to more than, I really just need to start visualizing it. Like, looking at this isn't gonna help that much. What do we got to pearl in? Like, it just... the numbers don't look right. It could just be, like, thinking about it wrong, though. Alright, let's figure out what we're actually trying to achieve here, then. So what I'm gonna do is, with this Perlin noise, I'm going to basically pause is going to be equal to the id index divided by the world radius. Times 2 and take away world radius, something like that. Cast to float. Let's make sure we got that right. Interesting. Very wrong. Cool, love it. What am I doing here? Bring out the old calci. So we're going 0 to like 1024 or whatever, right? Like 128. So we'd go... Actually, Perlin count, my bad. So the count divided by the world radius. So 128 divided by, what, 1024. That'll show us how many times we can fit into it. Maybe... or the other way around. Brain's gonna explode. I'm not very good at math, bro. Alright, what am I trying to do here? what will that give us? Yeah, okay, that's what I'm after. And so that'll give us like what to increment by. So we'll just call that like fucking interval. Cool. So interval times it by the it, take away the world radius. And that should give us a position. Not quite. Not quite. The world radius, take away. Or 1 times this by 2. Don't know if the brackets are necessary. No, because it's a left to right. Okay, world radius times 2 divided by the Pelton count. Give us the interval. So then the interval times it by it. Take away the world radius. Should give us something we can use. Yep, sweet. Beautiful. So that'll give us the position. And then now we just gotta like debug that somehow with I don't know. Well, this isn't init, it's not every frame, so we could do something like well actually we could go debug. I think we can literally just debug pause. Debug push debug something. Debug rect. P1, P2, we can do line create. That'll work. Alright. So pause. Pause 0, and this will be XY pause up to 10, and we'll change this to be the Pelton noise so we can visualize it, and then we'll just make it like red, and we'll put the tick count up to like fucking a lot, so it stays permanent, and then that's it for now. Sweet, that's exactly what I wanted. Fuck yeah. Actually, can we like make it more bulky? Make it more chunky? Scale 2. That's not really what I was after. That's not really what I was after. Oh, it kind of is though. Kind of is. Why not? Alright, so now we just sample into the thingamabob. Yeah, that'll work, that'll work. And then we'll just go noise. Let's call it there, I guess. Jesus fucking Christ. Oh no. Oh no. Divided by 128. No, divided by fucking 32. Okay, it's more sane. doesn't feel right. It's going past the boundary. Maybe we don't times it by 2. Okay, no, we do times it by 2. Bracket? Question mark? Question mark? Like, I'm expecting it to stop right here, because it's the world boundary. Clearly I fucked something up. Interval times it. Or maybe we go it divided by 2. Then we go interval divided by 2. Nope. What am I fucking up here? Maybe we don't times it by 2. You know what? Why am I even bothering to center it? That's what I want to know. Why on earth am I bothering to center it? Let's do that. Sweet. It still goes past further than I thought it would. Maybe that's the scale talking. Ah, it was the scale talking. My bad. My bad. Okay. It just gets bigger and bigger over time. Don't know what the goal is there. I wonder if I can just disable the entire world from drawing. That would be cool. World render. False. Sweet. This is such a scuffed way of debugging this. I don't know why it's increasing over time. I guess we'll just fuck around with some stuff then. We add. We just do 1 octave. What happens? It does the same thing, which is peculiar. Alright, well, let's just focus on getting the 1 octave right. Alright. Probably better if I dump this out into a texture. Nah, that'd be too much effort. Or would it? I'll do that later. Now, even with the octave count at 1, is that not going to do 2 octaves? And recycle 800. Could I? Nope. Recycle right here. All right. The octave count. Why the fuck is that undefined? What? Why are you not showing me what I want to see? Very sad. Me sad. Anyway, if we just like play through that. Huh. Okay, it is only gonna work once. That's cool. We're chill, bro. We're chill. What does the noise look like at this point? Why is the total amp 1? Alright, because it's only 1 octave. Okay, makes sense. I'm definitely fucking something up. Max value plus equals amplitude. Yeah. Something is wrong. I am doing something wrong. Like, it's not being normalized correctly. Why is it not being normalized correctly? Alright, let's just fucking step through it one by one. That's gonna be the best way of doing things. That's gonna be the best way. Alright. So, we got the interpolated value to be 0. Cool. What about this one? 0.69. 0.13. Like, it just goes up. Why is it going up? I'm doing the calculation wrong, aren't I? Like, this is wrong. Silly, bro. I'm so silly. When I was copying it down, I was like, I'm gonna refactor this slightly, and then I forgot to actually do the thing that I was gonna do to refactor it. These index into the gradient. Oh, I'm a silly goose. I'm a silly fucking goose. What a silly goose moment. This really do be a silly goose moment. Alright, much better. Much better. ChatGPT, never doubted you for a second, bro. This is all my fault. Human error, hey? Humans, am I right? Always doing dumb shit. Specifically Randy. Fucking piece of work, mate. Making errors everywhere. Just waiting for the day when ChatGPT can make the whole game for me. Alright. Alright, mate. Well, let's, now that you're not fucking dog shit, what do you got for us, buddy? Times you by 10. There we go. Now we're cooking with electricity. Okay, looking good. Perlin. Alright, so what does that actually look like? What does that look like? Oh my god, I just had mad deja vu. Jesus Christ. I just flashed back to when I was doing this like 2 years ago. Oh my god. Okay. Sweet. Just giving us some sexy numbers, you know. Just how it is. Now, I kind of want to like be able to tweak this on the fly. Like dial it in with a slider. That'd be kind of hype. Because I want to be able to like adjust frequency and amplitude and all this to like get a sense of what does what. If I change that to 1, then we're gonna get it out of bounds, of course. So let's get rid of that fucking warning. Get out of here. Okay. Yep. So we're getting an out of bounds. I'm assuming on the very last guy. It is 127, and what are we doing here? Left is 127. Yeah, so the right is the 128. So it'd be like, hey, what are you doing here, bro? Come Why you giving me an out of bounds, bro? Like we could basically have a wraparound. Which I feel like that's just what I'm gonna do for now. I don't know what ChatGPT would do. How would you handle wrapping the out of bounds here? I'd just say chuck a cheeky little percent in. Yeah, and just chuck a percent in, mate. Mirror. You can mirror it as well. Wow. Okay. Alright. Interesting. Yeah, what I'm gonna do is basically just fucking... So all we ever do is we sample into the gradients, right? Like that's what we're doing here. So going percent length, right, would give us our thing. Okay. If we change the frequency to something like 0.6, that just like changes how far out we go, right? Like how much of the thing we're sampling. Yeah. So now if we up the octave count to 4. Alright, let's make sure that we're doing this right. So I wonder if instead of like 0 to 1, like -1 to -1, we just go 0 to 1. That could be something we could do. Goes from 0 to 1, because the negative isn't really something we want here. And then +1 divided by 2. That'll give us 0 to 1. Sweet. Sweet, dude. I'd like to visualize it better. I don't know, I guess we just like increase the height. Now, what if we were to like just down it? So say let's just do 16, for example. And let's stop making the count line on the radius. Which is still a fixed interval, shall we? Of like 10. Okay. Now we're cooking. 32. Alright, sliders would be very helpful here. So I can get a sense for how this bad boy works. So generating it on the fly each time probably isn't the play. Like we probably want to cache out this gradient, and then we just do the lookup into it on the fly. What did old mate call it? What was this permutation? Why don't we just yoink this and use it? What about using Ken's original permutation table instead of the random generation? What do you say to that, Mr. GPT? What do you got? Come on, bro. Oh shit, what do we got, bro? Table is duplicated to allow for easier wrapping of indices. Generate the permutation table. Oh damn. Yo. Consistent and repeatable. TM. Oh, you still need the random gradients? Contains a random gradient vectors using the noise calculation. I thought... I should probably just read this to understand it better. Double permutation to avoid overflow. Interesting. So you double it to avoid the overflow instead of just like percenting it. Interesting. Array is used in a hash function that will determine what gradient vector to use later on. Especially this will be explained later. Okay. This is like a 3D poem. is calculate the dot product of a randomly selected gradient vector and key location vectors. Bit flipping code. Word. This man's just not on the same level as Ken Perlin, you know. How can you not understand this? It's fucking easy, mate. It's easy. This is actually a really good walkthrough of the entire thing. Which I'm actually gonna just yoink and then put a to-do in here. Figure out how this actually works. Lol. But for now, like, I'm literally just gonna take that because it's good enough and just dial it in for the fucking for what we need it for, which is the flint. Later on, like when I need to more robustly figure out how this works, I'll do it. But for now, I'm literally just gonna cowboy the shit out of it, which has always served me well in the past. How many octaves do we want? So it doesn't really matter at this level of detail. We go 64. That might be a different story. I want to be able to like just hot reload this or tweak the values. Create like a debug slider. Probably want to do that. That would be good. Debug slider / visualizer for this. In the meantime, how are we going to get this looking the way that I want it to? I guess like what we could do here, right, is oh, I need that fucking, oh, goddamn, what's that app that Cherno uses? Zoom it? I need Zoom it. That in the old programs, eh? Zoom64.exe. Fuck yeah. So now, oh yeah. Alright, so what I'm thinking is we literally do something like above this line. This is where we'll get our, if anything above this line, if the point is greater than this line, then we'll spawn the flint. So that'll give us nice little clusters like this. right? I think that's probably going to be a decent way of doing things. We probably want to be able to like fine tune this more and like visualize it. In fact, alright, the goal by the end of the day is to be able to easily visualize this generation. That's my goal. So for now, literally what we're going to do is well, we're going to use this as a... Fuck, what am I going to do? What am I going to do here, mate? What are we doing? There's like a couple things we want. We want like... we want to define the entire radius of where we're generating, which is the world radius. Like, that's what we're using for now. So I want to make this easily extendable once we start doing biomes and shit, and we're not relying on the world radius. So I'd say like length, size. World radius times 2. Starting point equal to negative world radius cast to float. So that's the starting point and that's a size. And then from there, what are we going to do? We basically want to define an interval. So interval something like 10, whatever, right? So then count, max count, it's going to be equal to the size of the interval divided by the size. Put this all in here so we don't have to worry about it. Alright, so then that's the max count. We'll figure out what the max count is. What do we got? No, that's not really what I'm after. Other way around. So the size divided by the interval? No. Yeah, size divided by interval. Yeah, that'll give us a count. So we got 200. So we're gonna have 200 things of flint, right? And then the next question is, all right, so we take that max count, and then we use that as the length of the Perlin noise buffer. So, use that as the count. Which isn't going to work because, you know, we need it to be a constant. So to get this bad boy be a constant, we just make everything a constant along the way. Sweet. want to make this an in. Sweet. So that'll give us like an interval. So we have the interval and we have the like how many times we can do it. And that'll give us our thing. So we for 0 to the max count. Right, and then noise is going to be equal to the purlin at the it, and then basically just create a new Flint item. Equal to the it times it by the interval plus it by the starting point. So starting point plus that, right? And that should just give us a bunch of Flint along the way. We've got to turn back on the world rendering. Max count take 1. Oh yeah, there we go. Also get rid of this, not using that anymore. So that'll just give us evenly distributed Flint all the way at the end. Beautiful. So to start off with, let's up the interval a bit to like 30. Sweet. Awesome. Maybe like, yeah, 30 will be good. 20, maybe. Yeah, 20 will be fine. And then let's I'm gonna add a bit of jiggle to it. So just go like -5 and 5. Add a little bit of randomness to it. 10 and 10. There we go, yeah. So that's pretty good. Alright, and now we basically just slice out of that. And to do that, we basically go if the noise is greater than or less than like 0.7, then continue. Which will give us clusters. Clusters of Flint. So that's a bit extreme. Pull that down to like 5. This is where I'd need the visualizer. So that's a bit much. 6. Sweet. So that's feeling pretty good now. Like it's sporadic, you know, but it's also got clumps. Awesome. That's exactly the vibe I was going for. Sweet. Alright, well that's the Flint generation. We've kind of called there. I'd like to be able to visualize it. I'll do that when we've got more important things to visualize, I'd say. So basically, I'll just say creates and spawns Flint at a fixed interval, then uses purlin noise hello. Hold up, give me a sec. Alrighty, I think I may have accidentally scuffed the recording. That's alright. I'm back. What the fuck was I doing? What was I doing? Actually, I think I just had my num lock off. Should be right. Hotkey still working? Yep. Easy. Alright, boys. Let's get cracking. Just doing something. Can't remember what. I think I was just kind of finishing up on the flint spawning. Yeah. Things are slowly coming together, you know? I would like to be able to debug. Not debug, but like visualize how the spawning works. So I think I am actually going to set up some cheeky little fucking debug visualizers. That'll be good. It's got to be done, mate. It's got to be done. So let's bookmark that, and then let's just go. Do we have like a? I've got an update. Like there's a lot in here. How am I gonna do this? Like I could change how much of them are hidden. I could use the same seed and just regenerate the world. I'm kind of leaning towards regenerating the world. Would I do that every single frame when I change it though? I don't know. Like, me hitting R here is regenerating the world. Now if I keep it at the same seed and then just tweak the parameters, should be fine, right? Yeah, should be alright. Alright. Let us get some kind of debug UI in there. I've already got some debug UI here. So let's just use this. Let's just reuse this here. Should be fine. Alright, let's do it. What am I doing? I'm just displaying all the entities here at the moment. What would we call this? Like a value slider? Tweaks? Probably the best way of doing things. Tweaks. So we go if tweaks. Go like UI tweaks. Show UI tweaks. And then we'll just literally do this. Alright. And then DTT. Ooh, cheeky. Alright. Is key. To go key pressed. It's literally going to be the one. Key pressed and we're debugging. So this will all just get compiled out. So if debug. This will just be like a whole thing. Gonna get rid of all this for now. Okay, sweet. If show tweaks, which we will just keep out here, I guess. False. Cheeky little global. Sweet. Show cursor, of course. Just fucking do that. And I'm pretty much just gonna copy this. Actually, now that I think about it. Alright, so get rid of that, call this tweaks. I'm just going to call debug. Debug. Rad. Make it true by default. Sweet. Alright, now we're cooking. So what do I want to do here? I basically want to have some sliders to manipulate some shit. Now, I haven't actually done sliders yet in my UI, but now's a good time to do it, I guess. I'm thinking like how we can do this. So what happens is like this gets called when we knit the world, right? So we could just pass in a seed every time we knit the world. So we're getting a random seed here based off the time. So I could basically say store this out in the app state. Just go world seed. Which we're going to store as AU64. Game state. We won't put it in the world because that gets reset. Although yeah, I'll figure that out later. World seed current 64. Times cold world seed. Set random world seed. Should basically just do this, right? Alright, so then we pass in the seed, so we seed the generation with all that stuff. Up the top here. Okay, set random world seed. Alright, so we do that. So now every time we run this, it should just, it'll be the exact same, right? It'll be 0. So we could have a button which says like seed. World seed or something like that. So let's just do that real quick. Button if button dot pressed random seed. Now we'll just set the random world seed. So then when we press this, we'll set the seed. So next time we reset, we'll have a different world seed. Sick. Alright, what do I want to do now? Sliders. Slider underscore float, I'd say. And then we're just going to we can start using some Jai stuff to do like cool runtime shit. Like how maybe we just have like a structure in we just have a structure here, which is like tweaks. And you would like put in your tweak. You just go like, yo, thing, float, or foo, vector 2, and then we would just like generate. That would just be editable right here, this entire thing. Which would be cool, I guess. Could also just manually do it. Oh, or you could even like tag stuff. Just be like, hey, add tweak, and then we'd loop over the entire fucking struct. And it'd look for everything tagged with tweak. Now that would be powerful. That'd be pretty cool. Alright, would it be in world? No. It's more so like, it's the world generation. World gen params. So it's like the world seed. And then we'd have parameters based off of that. So stuff like so the resource generation, the stuff that we really want here is so the interval we would want to change. How do we keep this constant? That's what I want to know. Do we need to keep it constant? Why do we need to keep it constant? Huh? Why on earth would we need these to be auto-bakes? That's my question. Non-constant expression in array declaration. Okay, that doesn't make sense. That's kind of cringe, bro. Just return a dynamic array. Fuck it. Fuck it, we ball. It doesn't even have to be dynamic. We just fucking do this. Like, it's all temporary, right? It's really all temporary. So we would just go make array. Yeah. Let's do it. Make array length. And then like the elements here. We don't even need to do elements. Actually, items. Float is equal to make array. This gives a dynamic array. We don't want that. Array. Just want to make a new array. Is that too much to ask for, bro? Come on, man. Come on, man. How do I want to do this? I was like making an array and then filling it with fucking things. I don't really want that. What I want is more like... Surely there's JI functions for this. Some standard stuff. Where am I trying to go? Here. Like ideally, I'd just go like new array. That works. Count, type, initialize. Yeah, that's exactly what I want. Exactly what I'm after, mate. Count, length, then the type is going to be float, and then initialize true, allocator. I'd like to say is the temporary allocator. Push allocator temp. that should give us what we want. And then same for this guy. New array length float. Sweet. And that should just work. Alright, no value bakes required. Now, yay. Yay for us. So now we don't have to have these motherfuckers be constant. So that would be cringe. Alright, what are the params? I'm after recycle. So what we want to be able to alter is, for one, I'm gonna call this like world gen params. Maybe. Flint interval. What else we got? Alright, what else do we got? Resource. No, we're in here. We want to alter the persistence. Which is, what we say, 0.5 by default. What else do we want? This next one's going to be an int, which is the octaves, which we'll set to 4 by default, or even just 1. Who knows? What else do we want? Frequency. Set to 1. And that's pretty much it. Sweet. This is world gen params for now. Oh, another one is like Flint threshold, which we said was like 0.6. Sweet. So now what I'm thinking is, when we generate the world, we basically just get a bunch of the params. Like we just use the existing params, I guess. So like st dot, maybe we do something like gen, st dot world gen params, gen dot seed, something like that, I'd say. Alright, so let's pass all these in, which we can do. How? Well, these don't need to be constant anymore. So we're chill. So we go gen.flint interval. That's one. This was gen.persistence. This was gen.octaves. What else do we have? Gen.flint threshold. And in here, we want some more things. So the frequency, st.weld gen.frequency. Make this a fucking macro. Of course, it's just called freq. Did we have anything else in here that we wanted to alter? Persistence, octaves, frequency, flint threshold, seed. No, we're all good. Alrighty, now we just want to be able to alter this. So we want to be able to go st.gen dot. What's the first thing we're gonna do? Say like flint threshold. Why not? Alright, and then what we're going to do is go current min max and then name flint thresh. Something like that. Sweet. Alright, now we're going to add the widget to my UI thing, which was heavily inspired by Mr. Ryan Fleury. What do we got? Let's plonk it down here, shall we? Right here. So we'll go slider, float. Return the updated float. Okay. What were the params? Current min max name. Let's get cracking. So we'll make a box with the flags of text. Say draw background. Draw. Don't even have like a background. Yeah, we'll say draw fill for now. So that'll give us the size of the box. It's gonna be tricky, but I'll figure it out bit by bit. You only have to do it once, and then we're pretty much Gucci. Okay, so we got this bad boy. Push parent, so that'll be the parent, and then let's just like chuck a label in here, see what that does. Cool, so we got the label. I want the hovering effects. Why aren't those working? I guess it's gotta be clickable. Sense. Still not working. We have to generate a signal. I always forget that. Sweet, now we got that hovering. Okay, so now we basically just want to like draw another box within this box. So we'll call this like fill. And we'll draw the fill. Good old fill, my man. And we'll just set the color to be like the secondary color. So set next fill color. We ideally want to like make it something, right? Like have this be like a secondary color variable, something like that. Or separate out background cull and fill cull. I think that's what Ryan did in his. Make box. Okay, so now we're going to make another one, which we will call percent. And then hash label. The reason these need to be hashed is because how the API works is they basically get cached into a what's it called? Fucking table thing. Hash table. They got hashed into a hash table. So they need to be unique. But don't want to display this on the end of the label because we're about to make a label. Or this actually isn't a label. Now if we did want to, you know, do that and still have it say test, like, you see the hash part isn't coming after the end. So we can still like make this unique however we want, but still have that be displayed. So that's why that's happening. Yeah, let's keep on this. So hash this as fill. Underscore fill. There we go. So now we've got a solid white being filled. Like gray. I'm concerned as to why that's not giving us the hover effect. Kind of confusing. I don't know why. Like you would assume that this is still doing its thing. I'll figure that out later. So that we can basically go like set next pref width, and that can be like a percent of the parent. Okay, percent parent. So there we go, 50% right there. I don't know why that's not propagating down to its child. Probably have to render it differently. Now that I think about it. Figure that out later. Okay. So now what we do is we basically like click and then we get the position of the click. And it'll just set it to wherever we need it to be, right? That's what we want with the slider. With the slider. So what I want to do is basically go like current to do update current from click, but now once we actually have that, we go like current and then down alpha. Make this a new function called float alpha. So we'll say, so we'll pass in the current, the min, and the max. Float, which is like similar to float map, but it's to an alpha value instead. So I don't have to keep thinking about how the fuck to do this. So we go by the difference of max take min, right? I don't know, something like that. That's why I wanted to put it in a function, so I never have to do it again. Keep fucking spelling flare wrong, dude. You need to stop typing so quickly and making mistakes. Alright. That'll give us the alpha. And then that will say, hey, that's our percent of the parent. Let's go. Let's go. Alright, so what's the 0, 1 Flint threshold? What's the default Flint threshold? We should be setting the default. And then we're returning it, of course. So we have to actually just pass down the current. There we go. So that's right on like 0.6 or whatever it was. Cool. That works. Float alpha. Do we want to clamp it? That's the thing. If clamp, then res. I gotta change this to like do clamp. Clamp, res, min, max. Or we got clamp result here. Yeah, it's just as good. Clamp result, then res equal clamp. Yep, okay, cool. And then we return the res. Yeah, by default we'll clamp it. Why not? It's kind of what we expect, you know. Ooh, actually, we want to clamp between 1 and 0, right? Sweet. Awesome. All right. Why isn't that label showing up? Oh, it is. It's going down there. So I want to make this set next set flags. Yeah, there should be a next flags. I'm just, or I don't have the file open. Okay, let's get the file open by doing that. Yeah. This is all generated at compile time. Sweet. We should have the autofill on that. Wherever I was. Car mover. Slider. Cool. So set next Loading. There we go. So now it's on the thing. Okay. Getting there, getting there. Sweet. Ideally we put the name in here. So we go that. Assuming we don't hash it. Figure that out later. Sweet. Getting there? Alright, the next step is to actually make it adjustable. So, we got the signal in here. And the signal in the box will give us... hovering, pressed, down, released. Kinda want the down. If signal.down, then we're gonna drag it to the mouse cursor. So to get the mouse cursor position, how do we do that? Screen mouse to cardinal, eh? Something, something. Let me check the rect. What does this do? This just puts us into the right space. Kind of scuffed, but it works. As with everything. Alright, so if the signal's down, how do we get the... Ooh, that'll give us some mouse position. Okay, cool. 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 Screen mouse cardinal. Mouse. It's going to be equal to that. Then I'm going to log this. Fucking hell. What? I don't like it when that happens, man. I don't like it. Log mousey mouse. Come on, bro, I want to log the mousey mouse. I'm slowly losing my mind. Okay, sweet. So that'll give us basically like the position. And then we'll just go box.rect. Like if it's in that. Basically want to like the min. That X. So now we basically want to alpha this, right? Float alpha. So we got the mouse.x, and then we want to do that, and then the max.x, and we want to get the alpha within that. Which, what if we plug that into the fill instead? Is that going to give us the right values? Look at that. Exactly what I want. Sweet. So we'll call this slider hover alpha, or slider mouse alpha. Right? And then, so if it's down, what do we want to do here? Alright, if it's down, then we just want to update the current. So we'll say slider val is equal to the current. And then, so if we're down, we basically want to go like slider val is equal to max take min times the mouse alpha, I would say. So that'll give us the slider val, and then the bar alpha can be calculated based off the new slider val, and we'll return the new slider val. The bar alpha, plug that into there, bada bing, bada boom, we should have a working slider, just like that. Oh yeah, sexy. Okay, maybe we don't want to do the hovering. We want to do the... because it's not going to be down when we drag off, right? What about... yeah, when we drag off, it stops being down. So we kind of want like a dragging signal. How are we going to do that? I wonder. So if clickable can interact, signal pressed, true, consume key. Alright, so this is where we do the clickety clackety. Men not hot. Dragging, okay, signal dot dragging is true. Basically want to do like if key released signal released is true. Weird because that releases the moment we pop off, which is weird. Or it's because if it's hot. Okay, that makes sense. We don't want to be doing that. So what if you accidentally move the mouse? Release. If We almost need the signal to be cached. Almost need the signal to be cached. Would it make sense to cache the signal? Kinda? How else are we gonna know? Like, we click on it and then we drag off. All of a sudden it's like, okay, were we dragging to begin with? Who knows? It depends on the initial click. So we do need to cache the signal, I'd say. Hot tea, active tea. So we have like a hot box, right? Hot box, active box. Yeah, let's just cache the signal. Fuck it, we ball. Wonder if that will have ramifications. Find out next week on Randy Programs UI. Holy. What am I doing now? Signal from box. Okay, let's go. So the hovering just gets kind of updated straight away. Right, like, yo, let's do it. Signal. Box.signal. Let's create a little alias for it, shall we? Cool. Alright, init. Now we can go signal dot down. So if it's down and the key gets released, then we're gonna release it. Yay! Should be good. This will probably fuck up my state a lot, but should be right. If key released down and released, then we got the signal got released. Signal. I'll just change that to false as well. To be fair, dragging is kind of like the same as pressed. So let's just get rid of that. For now. Sure, we need it someplace else. I don't know. We don't. We kind of need like a delta off the drag. Ah well. Sort that out later. So now when I drag off, it's still gonna be fucky. Let's see. Alright, now I've completely fucked things. Now I've royally fucked things in the anus. Shit gets cached. So we need a signal dot pressed equal false. false. Signal dot down equal false. Almost want to like let's create like an entirely new signal. So we get old signal. So we'll cache it. Just empty it out. So scuffed. Get it working though, and then fix it later. If the old signal is down, the key is released, then signal.released is true. Okay. We need to propagate the down. So we basically got to be like, if put this out here. Oh, there's too much state jank going on. Way too much. I have it's clickable and can react. Alright, what are we doing here? Oh, this box is hot. You mad thing in it. If frame is not hotbox and signal is hovering, then we're the hotbox, bro. We are. So now we'll go like. If key down, if the key's down and the old signal, I don't know, dude, this is fucking scuffed as shit, bro. You fucking scuffed me in. If the old signal is down, the old signal. Just propagate it. I don't know. Oh, now we're not even doing the down. Okay. If hotbox, key pressed, if key down. Okay. So now, if it's not the hotbox, if old signal got down, let's copy across the old signal down. Signal down. Old signal down. Oh man. I think it's gonna make a difference if we fucking do it. Like here. I don't know. I don't know, dude. Nah. Signal dot down. This is so fucked. Oh god. Key down. That should be working. It's not though. Alright, I think I need to resync this whole thing. Alright lads, I gotta go dip for some dinner. I will catch you tomorrow and we'll fucking sort out the rest of this. Alright, peace.